solutions. The solution to a system is a combination of values for each variable that is a solution for all the equations involved. If you were looking at a graph, this would be the intersection point or points between the lines or the curves. So if we look at this point 2, 5, and if that is a solution of the system that I have here, then what would happen is if we plug in the 2 and the 5 into both equations, the equation would hold true. So 3 times 2 plus 2 times 5 is 6 plus 10, which is 16. If we do negative 2 times 2 plus 5 times 5, that is negative 4 plus 25, which is 21. So since plugging in 2 and 5 worked for both equations, that is a solution to that system. There are several ways to solve a system of equations, and the first method I will show you is the substitution method. And to do the substitution method, we first need to solve for one variable. So what we want to do is choose one of the equations and solve for one variable in terms of the other. So if I have 2x plus y equals 5 and x plus y equals 2, I could choose the y from the first equation or the x or the y from the second equation. I would choose those because the coefficient is 1, and it's easier that way. So let's just take this first equation and solve for x. To do that, I would subtract the y and get x equals 2y, 2 minus y. So I've done that. I have done step 1. I have solved for a variable. Step number 2 would be to take that and substitute. And you'd substitute the expression from step 1, in this case the 2 minus y. We would plug that into the other equation to get an equation involving only one variable, and then we would solve for that variable. So I would take, in this case, the 2 minus y, and I would plug it in for x. So I have 2 times that expression. So 2 times the 2 minus y, and then plus the y, equals 5. So the only thing I changed was I replaced x with the 2 minus y. And now I would distribute, and I would get 4 minus 2y plus y equals 5. I would solve that and get y equals negative 1. I would subtract the 4 and divide, and these would give me negative 1. I would divide by negative 1. And then, when I have that, I would then go on to back substitution. And what that means is I substitute the value from step 2, in this case the negative 1, back into the expression from the step number 1 to solve for the other variable. So I'm taking this negative 1 and I'm going to plug it in right there to that y where I already had x equals. And so I'm going to have x equals 2 minus negative 1, which is x equals 3. And therefore my solution would be 3, negative 1. So those are the 3 steps to follow for substitution. Okay, let's look at an example without going through all the steps with all the wording. So here I have 2x plus y equals 1 and 3x plus 4y equals 14. If I look at the 3 of these terms, the one that I would solve for is the y, because that's the one variable term that has a coefficient of 1. So to do that, I would subtract the 2x, and I would get y equals 1 minus 2x. When I take that, I'm going to take that 1 minus 2x, and I'm going to plug that into the other equation in place of y. So 3x plus 4 times 1 minus 2x is equal to 14. So then I go and distribute the 4, and I get 3x plus 4 minus 8x equals 14. Combine your like terms. I get negative 5x. I'm going to subtract the 4 to get negative 5x equals 10. So that x is equal to negative 2. Now I'm ready for step 3. I'm going to take that and I'm going to substitute the -2 back into the x value, x variable right there, for y equals 1 minus 2x. So y equals 1 minus 2 times -2. So that's y equals 1 plus 4, which is 5. And therefore, I have an x and a y to give me -2, 5 for my solution. All right, so let's look at this other example. This one has x squared plus y squared equals 100, and 3x minus y equals 10. Generally speaking, if I can avoid having to solve for an exponent or exponential term, I would do that and solve for a linear term. So I have to choose 3x or the negative y. I would go with the negative y just because that's a 1 for the coefficient, but it is negative, so we're going to have to divide by -1 once we get y by itself. So we're going to subtract the 3x. We get negative y equals -3x plus 10. You always want to write the, anytime you're solving for a variable, it's usually good to get in the habit of writing the variable term first. Now I got to get rid of that negative, so I'm going to divide by -1, and I'm going to divide every term by -1, and get y equals 3x minus 10. So now I'm ready to substitute, and I take that 3x minus 10, and I'm going to plug it in for y. And I get x squared plus the 3x minus 10 quantity squared equals 100. Be careful, when you square 3x minus 10, you have to use the FOIL method or box method. So you're taking 3x minus 10 times 3x minus 10, and you're going to have to distribute the 3x to both terms there and the -10 to both terms, and you will get 9x minus 30, sorry, 9x squared minus 30x minus another 30x, and then plus 100. And that gives me 9x squared minus 60x plus 100. And now let's go ahead and put that back up here. So x squared plus the 9x squared minus the 60x plus 100 is equal to 100. Now I need to combine my like terms, and I get 10x squared minus 60x plus 100 is equal to 100. Now I have a quadratic here, so I'm going to set this equal to 0. I'm going to subtract 100. And that actually cancels out both of these. And I get 10x squared minus 60x is equal to 0. Now, if that didn't cancel out and I had a number here, you would just need to factor the quadratic using a factoring method or quad 3 on your graphing calculator. In this case, the constant canceled out. So I look at the two terms here and I notice that I have a common factor of x. In fact, a common factor of 10x. So I'm going to factor out 10x, and I'm going to have x minus 6 in parentheses. And now I have two factors set equal to 0, and that means I'm going to set each one equal to 0. I get 10x equals 0, which means x is equal 0. And I have x minus 6 equals 0, and I'm going to add the 6 and get x equals 6. And I have two values for x. This does not make my ordered pair. I just have two values for x, and I need to go back up here where I had y equals 3x minus 10 and plug in 0 to solve for y, and also plug in 6 to solve for y. So y equals 3 times 0 minus 10, and I get y equals -10. So that ordered pair would be 0, -10. And when I plug in the 6, I get y equals 3 times 6 minus 10. which is 18 minus 10, and I get y equals 8. So the ordered pair from that is 6, 8. So in this case, I had two ordered pairs as solutions, which means my graphs intersected in 2 points. Okay, looking on to elimination. Elimination is another method of solving systems, but we need to adjust the coefficients by multiplying one or more equations by the appropriate numbers so that the coefficient on one of the variables in one equation is the negative value of the coefficient on the same value of the other equation. So if I'm talking about, let's say 2x plus y equals 8 and 3x minus y equals 10, I can do this by adding the two equations together. I have an opposite y term here with positive y and negative y. If I don't have that, I need to multiply. Let's say if we look at the x term here, and I am looking to eliminate x, I would need to multiply the first equation by -3 and the second equation by +2, and that would give me -6x for the first equation and +6x for the second equation, so that I have opposite values. And now for step 2, we would add the equations together. So we would add the two equations together to eliminate one of the variables. The one here, if I were to add these together, the -6x plus the 6x would now eliminate and be 0. If I continued on, that would give me, for the first equation, if I keep distributing that -3, I would have -3y and -24 over here. And then if I distribute the 2, I would have -2y equals 20. Okay, so if I add these two together, my x's would eliminate. I like to draw these lines down here to separate my columns. I would get 0, I would get -5y, and I would get -4 when I'm adding these together. And now I would need to solve for the variable that is remaining. So here I'm going to solve for y by dividing by the -5, and I get y equals 4/5. And so with the y equals 4/5, I would then move on to step 3 and do my back substitution. So I would substitute that 4/5 into one of the original equations to solve for x. So to do that, I'm going to plug in the 4/5, and it goes into either equation. And I would get 2x plus 4/5 equals 8, and then I would go on to solve that to finish my step 3. So I would subtract 4/5. I would get 2x equals 7 and 1/5, which is 36/5. So 2x equals 36/5. And then when you divide by 2, you would get x equals 36/10, which is 3 and 2/5. So my ordered pair is 3 and 2/5, comma, 4/5. Okay, so let's look at this example here without going through the steps as carefully. I would do elimination by adding, or actually, yeah, I have the 2y and the -2y. It's already set up. They're opposites, so I don't need to multiply either equation by anything, and I would just add these two equations. So I'm going to split these up here. 3x plus x is 4x. Here I would get 0, and 14 plus 2 is 16. And I have x by itself, so I'm going to divide by 4. Then I get x equals 4. When I go to plug that back in, it doesn't matter which equation I choose. I'll go ahead and plug it into the second equation. So I get 4 minus 2y equals 2. I would subtract the 4 to get negative 2y equals negative 2. Divide by the negative 2, and I get y equals 1. So my solution would be 4, 1. All right. Now the last method would be graphing. When it says to graph the equations to find the intersecting points, we need to be able to graph the lines. We're not finding the intersection point and then graphing the lines. We are actually graphing the two lines, and then we will locate the intersecting point of the two lines. There's two ways to graph. You could set each equation and put it into y equals mx plus b form, or you could make a table of values, and I'll show you that to you down here. So if I put each one into slope-intercept form, I take the 3x plus 2y equals 2. I'm going to subtract the 3x here, and I get 2y equals negative 3x, because I want to write the x term first, plus the 2. And then I divide by 2, and I'm going to divide each term by 2. And I get y equals negative 1/2 x plus 1. Now that equation is ready for graphing. When I take this other equation, I'm going to add 2x to both sides. I get 3y equals 2x plus 16. I'm going to divide by 3, and I get y equals 2/3 x plus 16/3, which is 5 1/3. Now I have that equation ready to graph. So I'm going to go up here to 1. I'm going to graph this first equation right here. And my y-intercept is 1, so I'm going to go up on the y-axis and plot my value 1 for my y-intercept. My slope is negative 1 over 2. That is down 1 and right 2. So I'm going to go down 1. Oh, that's a 3. So down 3 and right 2. So down 3 units and right 2 units. And I could go down 3 units again and right 2 units. I could also go up 3, but if I go up 3, I'll be going left 2 units. So if I go up 3 and left 2, you can see my dots are staying within that line. So then I graph. Let me get a thinner line here. And I'm going to graph this line through those points. Okay, now with this other equation, I have a slope y-intercept of 5 1/3. So I have to go up to 5 1/3, which is right about here. And my slope is 2/3, which would be up 2 and right 3. But if I go up 2 and right 3, I'm going away from the current line that's on my graph. I want to actually go towards that line. So I'm going to go down 2 and left 3. So if I go down 2, I have to go down 2. Now remember that point is up 1/3 of a unit from the line. So when I go down 2, I have to stay at that 1/3 value and then go left 3 units. Okay, down 2, left 3. And I can graph this point or this line through these points, and it's a little bit off because of the 1/3, but you can see it's going through that point there. So I identify that point as negative 2, 4, and that's my solution. So that's how you find your solution by graphing. I could also do the same I could graph by using a table of values. If I label this as graph 1 and graph 2, for number 1, if I make an XY table, what I'm going to do is I'm going to start off by just putting in 0 for X. I'll find the Y that goes with that, and then I'll plug in a 0 for Y and find the X that goes with that. So if I have 0, 3 times 0 plus 2Y equals 2. Well, 3 times 0 is going to zero out that term. So really all I need to do is just divide by 2 and get Y equals 1. When I plug in 0 for the Y, I'm going to get 3x plus 2 times 0 equals 2. And this term gets zeroed out. So all I need to do is divide by 3, and I get x equals 2/3. All right? And if with definitely with one of your lines, it'd be nice if I didn't have to graph a fraction. So I could look at using a pattern to come up with other points in this table, because when we're talking about linear equations, there's patterns in the table because we increase or decrease by a constant value. So here we're going from 1 down to 0. That's subtracting 1. So subtract 1 again, I'm going to get -1. I could keep going and get -2. My x values are increasing by 2/3. So if I increase by 2/3 from 2/3, that gives me 4/3, which is 1 and 1/3. And if I increase again by 2/3, that will give me 2. So now I've got a point here, 0, 1, and a nice point here of 2, -2. So 0, 1, and 2, -2. And from that, I can see count, rise, or run and see, okay, up 3, left 2, up 3, left 2. And I can graph that line. And then go on to the next equation. So with the second equation, again, I'm going to go with x and y, and I'm going to do that 0 for x and 0 for y again. And I know that when I plug in 0, it cancels out the term for x, which leaves me 3y equals 16. When I divide by 3, I'm going to get y equals 5 and 1/3. So 5 and 1/3. When I plug in 0 for y, that will cancel out the y, leave me with -2x equals +16. Divide by the -2, and I get x equals -8. Since I graphed nice points with this first graph, I could probably get away without having to be so accurate with my second line. So let's go ahead and do that and see what happens. So -8, 0, 1, 2, 3, 4, 5, 6, 7, 8 is right here. And 0 and 5/3 is up here, 1, 2, 3, 4, 5, and 1/3. And I'm going to graph that line. And I can see that just like the graph above, my intersecting point is right there at -2, 4. So basically what you have to decide is which method do you feel is easier for yourself, and use that method because you have two different ways to graph the equations. And that does it for 6-1. Yep.